Right, so this was one which somebody asked me to go through. Okay, so y equals x cubed plus 4x squared minus 3x. All we have to do is find the stationary points. Now, first things first, before we do anything else, right, have a look at this. What type of curve is this? What type of curve is this? So this one over here was a quadratic curve. This kind of shape. Happy face. What type of curve is this one?
Cubic.
It's a cubic curve, which means that it turns how many times?
Two.
Turns twice. Like, think about it. Quadratic curve, highest power is 2. It turns once, right? Cubic curve, highest power is 3, which means that it turns twice. Good, Megan. So it means you're looking for something that looks like this. Okay? It's a positive cubic because, again, it starts with a positive coefficient. Leading coefficient is positive. Okay? So we're looking at that. So how many stationary points do we expect? 2. Okay? So there's one there, and there's one there. Okay? So with this one, a quadratic curve, it only turned once. Therefore, there's only one stationary point. Here now we're expecting 2 stationary points. Okay? And in fact, that's a general rule of thumb. You look at the highest power of your equation, and then you reduce it by 1. That will tell you how many stationary points you expect. Okay? It may not always be like that. Like, there's some cubics which only turn once, but we'll talk about that in just a second. Okay? But in this case, we're expecting 2 stationary points. All right, let's have a think about how we could do that. So what's the first thing that we need to do? Differentiate. So if we differentiate it, what do we get?
3x
Minus 3. Perfect. Okay. Now, we want to find the stationary points. So what do we need to do to find the stationary points?
Equals to 0.
What equals 0?
dy.
Perfect. So always say that. So a stationary point will occur when the derivative dy by dx is equal to 0. The gradient is equal to 0. Okay, so here's my gradient, 3x squared plus 8x minus 3. That's got to equal 0. Okay. And then I need to solve this. Now this is different to the ones that we're doing on the board. Okay, I'm sure you did other ones which were like this. Because now it's a quadratic. But that shouldn't be a surprise. Because when we solve this, the quadratic, how many solutions do we expect? 2. And that makes sense because we're looking for 2 stationary points. Right? Okay. So it's slightly more awkward to solve because it is a quadratic. Does it factorise? Can anybody see it could factorise? I think it does. I think it does. Yeah, so there's 2 solutions, or there's 2 ways you get there. You can either see if it can factorise, and it will factorise, so we will do it that way. If you can't see it, though, how else could you do this? How else could you solve this equation?
Completing the square.
Completing the square, absolutely. Or more generally, you could use the quadratic formula. Remember, completing the square quadratic formula is the same thing. Yeah. So I would usually spend about 20 seconds looking at it. If you can't work out whether it factorise or not, particularly for non-monics, just go for the quadratic formula because it will always work. It will always work. It just takes a bit more time. Okay. So let's see if we could factorise this. So come on then. How do we factorise non-monic quadratics? So first things first, we look for 2 numbers that multiply together to make 3 multiplied by negative 3. The 3 multiplied by negative 3. Remember that? Okay. So we're looking for 2 numbers that multiply together to make negative 9, and which add together to make positive 8. Okay, positive 8. So remember, it's slightly different for non-monics because you need to multiply this number by this number. But if you remember for monics, because that number was just 1, you'd end up multiplying 1 by that anyway, so it's just that last number.
Yes.
Non-monics are slightly different. Okay.
X minus 1.
So sorry, what are the 2 numbers which multiply together to make negative 9 and add together to make 8?
3x plus 3.
Good, I can see where you're getting there, so you're slightly ahead of where we are at the moment. So what 2 numbers multiply together to make negative 9 and add together to make 8?
Negative 8. Negative 8. No.
Multiply together to make negative 9.
9, 1.
1, negative 9.
Sure, it's that way around?
Negative
1
1.
and 9.
Perfect. 9 and negative 1, because 9 multiplied by negative 1 makes negative 9. 9 plus negative 1 makes 8. 9 take away 1. Happy? Okay. So, now all we do is keep the first two terms the same. So 3x squared and the negative 3, they stay the same. Okay. And then all we do is split this negative 8 or positive 8x into 9x, positive 9x, and negative 1x. Okay. Does that ring some bells? Okay. And then all we do is just split the equation down the middle and just factorise each side separately. Okay. So if we factorise the left-hand side, the 3x squared plus 9x, what do we get?
X plus 3, I guess.
Yeah, so x plus 3 inside the bracket. What goes outside the bracket? What term have we factored?
3x.
Yeah, good. 3x is the factor. Happy with that? Now remember, whatever happens, this x plus 3 must be the same as the bracket on this side. So we know we must get an x plus 3 on this side as well.
1.
Good, because you're basically saying, yeah, negative 1 times x is negative x, negative 1 times 3 is negative 3. Great, it works. Okay. How do we finish this thing off then?
3x minus 1 times x plus 3.
You got it. So we factor out an x plus 3 from both terms. You happy with that?
We could have used the quadratic formula.
That's exactly what I said. Yeah, sorry, you missed it because you came in slightly late. Yeah, exactly. So I said, it doesn't take that long with a bit of practice. To be honest with you, I'm used to working with these, so I can just jump straight from here to here, and some of you may be able to do the same. But there is a process for how to do it. It doesn't take too long, okay, but it is a little bit more work. If you're not comfortable with this, remember quadratic formula is your friend. Okay. Happy with that, Megan?
We're still going to have 2 exam labs in this, or is it 1 exam?
Yeah, so you'll have an exam in about 5 weeks' time. Alright, okay, so then if we solve this, what are our 2x coordinates?
1 over 3 and negative 3.
Good. Okay. So these two values here, let's not lose track of what we're doing here. These two values, 1/3 and negative 3, correspond to the x coordinates of our stationary points. Okay? So we've got 1/3 over here and negative 3 over here. Does that make sense? So don't lose track of it. This is a quadratic question within a bigger question.
So if they ask for the y-intercept, they're going to be 2.
Well, I want the y-intercept, so I want the stationary points. So I must have an x and a y. But that's not too difficult, is it? Once I've got my x, I can find my y by
Put it in back in the equation.
what equation? There's two, remember, this one and this one.
Not the original.
Yeah, the original one, because remember, this one gives you the gradient. This one says, give me an x, and I'll give you your y. Okay? So, alright, let's do this. Shouldn't take too long. So we have y equals 1/3 all cubed plus 4 times 1/3 squared minus 3 times 1/3. Okay?
1 over 9.
Is it 1/9? Oh, sorry, you're going through. Yeah, sorry. 1 over
1 over 9. Oh, wait. 3 times 3 times 3. So it's 27.
27
Plus 4 over 9.
4 over 9.
Negative 1.
Good. Take away 1. Okay, so I guess we could tidy this up. We get 1/27.
Times 3, so 12 plus 12 plus 1, so it's 13 over 20 and 27.
Yep. 13 minus 27 effectively.
13 minus 27, so 1 minus 27, it's 14, negative 14.
Good. Well done. Yeah. So that's your y coordinate for your x. So you know now that at 1/3 your y coordinate is negative 14 over 27. By the way, I'm doing this in my head on the board, just purely because I don't have a calculator to hand. It looks a bit awkward with fractions. It doesn't take that long to type it in. I just stick it in your calculator. But I'm just showing you that you can do it by hand if you wanted to. Just fractions. Now for your other one, for x equals negative 3 should be slightly easier. So you get y equals, well, negative 3 all cubed, plus 4 times negative 3 squared, minus 3 times negative 3. Okay, so let's do this. Negative 3 squared. Good, negative 27. 4 times negative 3 squared.
4 times 9, so it's 36.
And then negative 3 times negative 3.
9.
Okay, cool. So therefore we should end up with 9 there plus 9 is 18? Yeah? So our y coordinate is 18. There you go.